Hello, everyone, and welcome to worksheet number 3, section 3 or 3, depending on your nationality, I guess. Anyways, so this section is a lot about linked lists and stuff. This is moving a little bit away from some of the details of Java and more towards kind of themes that we're going to see in the class in general and general kind of programming things. So hopefully if the first few were easy for you, or you were like, this is boring, I'm just doing basic Java, we're gonna start ramping it up a little bit at this point. That being said, this first question is a relatively straightforward kind of can you execute the code type question. I'm sorry for so many of these, but basically we're just given a bunch of int lists, and we're just supposed to basically draw out here what these int lists are going to look like at the end of execution of the function. So an int list, remember, is a specific implementation of a linked list. If you've heard the term ADT, abstracted data type, which we talk about in this class a bit, the abstract data type is a linked list, right? There's a lot of different ways you could implement a linked list. You could implement it with just length to arrays. You could implement it with a separate class, as we're doing here. This one is designed specifically to take integers because that's easier. You could implement it generically, which is what you do in project 1, right? The ADT is the linked list, right? So by definition, it's just something that has like an element and has a pointer to the next thing. And then this is a specific implementation of that ADT. Anyways, that's all conceptual stuff. Let's run the actual code here. Okay, so I'll just basically start going line by line. So first thing we're going to do is we're going to instantiate an int list L1 using intlist.of. Intlist.of just creates, in this case, a 4-element linked list. It just takes an arbitrary number of integers and just makes a linked list out of all those integers. This, by the way, keep in mind, is a custom class that we write in 61B. In general, don't expect linked list classes that you come across in the real programming world to have this convenient of method. They probably won't. This is just so we can set up our linked list really easily. Anyways, so L1 is going to be a pointer because the linked list is a reference type and int list is a reference type. And then it's just going to look something like this. We're going to have 4 boxes because we have 4 elements. Each one contains each successive element. And then the last one in our linked list contains a null, which I'm representing just with this slash, right? Okay, this is the basic structure of a linked list. These are the links, they're pointers, and it's just a list of numbers. Okay, so now let's start doing some of the spicier things. Int list 2, or L2, is going to be L1.next.next. So let's first start by just creating this L2 variable. This is also going to be a pointer, just like L1, but what is it pointing to? Because it's not creating a new linked list. It's pointing to some element of this original linked list. So the secret here, I think, is to realize that when we say .next, right, L1.next is not this box, basically, right? It's not this linked list node. What L1.next really is it's this pointer right here. The pointer points at this node, right? And in Java, if you say next.next, it will automatically know you want to go to this node and go to the next node, et cetera, et cetera. But keep in mind that when we're copying pointers like this, we're copying pointers, not actual nodes. That personally for me was kind of the secret to figuring out these types of problems. I used to mess them up a lot, but then once I realized we're rebinding pointers, not actual nodes, that's when it started to become clearer for me. Okay, so let's figure out what node we actually want to point to here. So L1 is this pointer, so it points at this thing. L1.next is this pointer, and then L1.next.next is this pointer, right? So we want to set L2 equal to this pointer right here. So that pointer is pointing at the node that says 22. So we're going to end up with that basically, right? That's what it means to copy a pointer. They're pointing at the same thing, right? Remember, not the node itself, just the pointer. Okay. Next line, L2.next.item is 13. Well, what is L2.next? L2.next is this pointer, right? Because L2 points at this node here, and then it has a .next. So .item refers to the item of this thing, of this final node, and we're going to change it from 31 to be 13. So let's just do this. Notice here that if you were to access this last node via L1, it's going to be 13, right? this is kind of similar to like a static variable, basically, in the previous worksheets, right? Where we're changing it with one variable and it's affected in another variable, right? If we access it that way, because they are the same object. Great, that's all that line is. L1.next.next.next equals L2. Okay, so let's go through here. L1.next is this thing. L1.next.next is this thing. L1.next.next.next is this thing. So we're rebinding this pointer here. Let me get rid of these circles. This pointer, and what are we binding it to? We are binding it to whatever L2 is. L2 is a pointer, and it's pointing at this node. So this is a little bit weird, but basically we are rebinding the next of the 22 node to whatever L2 is pointing at, which is itself. So if you were to call, this nodes.next, it would just give you the same node back over and over again. It's a circular reference here. Notice also that there's no way to get to the 13 anymore from any place. So Java is going to garbage collect this, and this is going to disappear. The official solution leaves it in the diagram, so I'm just going to leave it in. But if you erase this, that would be totally legitimate, because if you can't get there anymore, there's no reason to keep it in your memory, right? It's just wasting space. And Java will be smart and realize that it's no longer accessible. Anyways, great. So that's this line, which is probably the weirdest one. Now we're creating a new int list, L3, but we are not actually we are creating a new int list, sorry. We're going to create int list containing 50. So it's going to be a pointer to an int list just like that, 50, and then a null. This is a completely separate int list from the previous ones because it uses the new keyword. It's creating a new object. Okay, and now the final line, L2.next.next equals L3. So let's go to L2. It's this thing. What is L2.next? It's this pointer. What is L2.next.next? This is a little weird, but remember, this is just pointing back at itself. So it's the same thing, right? We could call .next as many times as we want. It would be the same thing because we have this circular reference. So we're rebinding this pointer right here. What are we rebinding it to? We're rebinding it to L3. L3 is a pointer pointing at this new node we just created. So we're going to rebind this like this. And that's the end of the problem, pretty much. That's how, oops, I forgot that got erased. But this is what it's going to look like at the end of the problem. Big takeaway here is remember that .next refers to a pointer, not an actual node. And if you can keep that in mind and realize that you are changing pointers, we never changed any nodes. Well, I guess we did change the value right here. Other than that, we never changed any nodes. These kinds of problems will hopefully go by pretty quickly for you. So that's the first part. Thank you for watching.